In example 1, we need to graph the equation y is equal to 3 cosine of x over 2. And in this case, x is going to be an angle. You could easily substitute theta in there. But anyways, x is this x-axis here, or the theta axis. We're going to be doing this by hand. So what we need to do is we need to figure out the amplitude and if there's a reflection or not. So for the amplitude, we're going to take this value 3, which is kind of A if you looked at the previous videos. And we're just going to take the absolute value of that. The absolute value of 3, of course, is just 3. Also, there is no reflection. We also need to note whether this is sine or cosine. That will tell us where to start. Remember that the cosine, basic cosine graph, y is equal to cosine of x or y is equal to cosine of theta, starts up 1. But in this case, this graph is going to start up 3. That's actually off the graph, so perhaps it's a poor choice, whoever made this graph, that they actually put the value of the tick marks there. Well, we can change those if we need to. So let's make this 2. Let's make this 4. This will be negative 2. And this will now be negative 4. Give some new values to each one of those lines. So we're going to start up 3. If this graph was reflected, we would start down 3. We need to figure out the period now. So the period, I hope you guys can see this here, I'll move that down a little bit. So the period is 2 pi over k. In this case, k is 1/2. If you want to think about this like 1/2 x inside, please do. The value of k is not 2 in this case, it's 1/2. So we'll take 2 pi and divide it by 1/2. Remember to multiply by the reciprocal, so the period is 4 pi. We also don't have 4 pi on this graph, so you could change the axes, the labels on the axes if you wanted to. But let's try to graph this thing, and we'll try to get at least one full period without having to change the axes. So we now know that the amplitude is 3. There's no reflection. The graph will begin here, and then the graph is going to repeat, or the y values will repeat after 4 pi. So if you imagine this thing stretched out a little bit, instead of coming down here and hitting 0 at pi over 2, that would be the normal y is equal to cosine of x graph. Actually, this is stretched by 2. Notice that the regular graph y is equal to cosine x has a period of 2 pi. This one has a period of 4 pi. So all those x values would just be stretched by a factor of 2. So we need to come down here at pi. If you wanted to see if you were right, you could substitute in pi here, and pi divided by 2, that's just pi over 2, or 90 degrees. And the cosine of pi over 2, or 90 degrees, is 0. 3 times 0 is 0. So we should have a y value of 0 at pi if we substitute into the formula, or into the equation rather. We now can see maybe the first quarter of this graph. The next quarter is going to go from pi to 2 pi. Remember that the cosine graph starts in the positive area here. It's going to hit 0 and then come back down. And we want to go down that distance that we were given in the equation. And that amplitude is 3. So we want to come down 3 units just like we went up 3 units. We could continue this on a little bit, although we're going to have to see a 3 pi over here, which is just a little bit beyond the graph. So we can stop here. As we go to the left, this is just going to be a reflection or a mirror image. So at negative pi, we're going to have a mark at 0, and then here at negative 2 pi, we'll come down. And we'll actually have graphed one full period here. So if we do that, let's try to do a nice job. Make sure that it's curved. Okay, this is not some sort of absolute value graph, so it's not going to be perfect, but just try to do the best job that you can. If you wanted to plot more points, you'd get more and more precise, because this graph is simply just all the coordinate pairs, oops, that would make this equation appear true. I'm going to draw an arrowhead here because we're not told to graph over an interval, so we need to keep this going. One of the big things about sine, cosine graphs, and the trigonometric functions for that matter, is that they are periodic in nature, and that they go on forever in either end, have a domain of -infinity to infinity. So here we've got one full period, it appears that our amplitude is 3 from the midline to the top line, or from the midline to the bottom line. And you can draw those if you wanted to help yourself out. Midline would be right here at the x-axis. And then from negative 2 pi to 2 pi, this function repeats, so that's a period of 4 pi, which is indicated by the value of k substituted into this formula.